This video is going to talk about using distance to identify shapes. First off, remember that to identify points on the same line, you want to look at the coordinates. For example, the same x-coordinate means that the line is going to be vertical. Having the same y-coordinate means that the line is going to be horizontal. Remember that to remember the difference between horizontal and vertical, I write the first letter of each of those words, because the V in vertical is the bottom line, is the bottom arrow of an up and down line, and the bridge to the H in horizontal is a horizontal line. So if we have the points -2, -3, and -2, -8, and we want to figure out which of these two lines on the coordinate plane it's going to be, we have two potential vertical lines. We have potential A, we have potential B. To figure out where this point is, we need to figure out how far do we run to get to the line. So if I start at the origin, and if I'm going to run -2, that means I'm going to run in the negative direction. Anything going in this direction is going to be running in the negative direction, which means that the first number is going to be negative. If I run over in this direction, the first number will be positive. And because both of these points are negative, it's going to be somewhere over to the left-hand side. Now the second number, if I'm going to jump up high, that means it's going to be a positive, which means that anything that is above this line is going to have a positive second number or a positive y-coordinate. Anything that is falling down would have a negative. These are quadrants right here, and what I like to remember about quadrants is that if you think about a clock, the number 1 and the number 4 are in the correct quadrant on a clock. So, for example, this is quadrant 1, this is quadrant 4, then it just goes in order. We have quadrant 2 over here and quadrant 3 over here. So, in order to figure out which line the points are on, I see they're both negative, which means they're both going to be either in quadrant 2 or 3, which means it's going to be on line A. So what quadrant was that point -2, -3 in? Remember back here where we had these signs listed out here, plus, plus, minus, plus? These are two negative numbers, that -2, -3, which means they're going to be in quadrant 3. The other point, which was -2, I believe it was -8, is -8, is also going to be in quadrant 3 because they're both negative. So what we keep in mind is that now we want to know, is the second point above or below the first point? Well, the second point is going to be below the first point because you're going to fall down 8 instead of falling down 3. The distance between the points is going to be 5. If I fall down 3, I need to fall 5 more to get to that -8. So if we look at the distance between these two points, because the x-coordinate is the same, we're going to look at the y-coordinate. To go from -3 to 5, we're going to set up a number line here. Negatives are going to be on the left, positives are going to be on the right. We would have 0 in between. That's not exactly where 0 should be, but it's going to be close enough. To go from -3 to 0 is going to be 3 steps. To go from 0 to 5 is going to be another 5 steps. So when we add up all of those steps, the distance is going to be 8. The distance between these two points, again, that first number is the same, so we're going to look at the second number. Now on this number line, with the negatives over here and the positives over here, I have 1 and 8. 1 and 8 are both on the same side of 0. So I want to know how many steps is it to go from the number 1 to the number 8. 8 minus 1 is 7. So that's going to be 7 steps. The distance between these 2 points, now I can see that the y coordinate is the same. So I want to look at the x coordinate. These are both on the same side of 0. They're both negative. So I want to take the absolute value of each number, the absolute value of negative 41, minus the absolute value of negative 23. The absolute value of negative 41 is 41. The absolute value of negative 23 is 23. And I would subtract that to find the distance between. So we have a shape here, but we can't see the shape because all we have are the points for the shape. We want to know which sides of this quadrilateral are horizontal. Well, remember that in order to be horizontal, we're going to want to find points where the second number is the same, because we're going to want to jump the same amount and run different directions. So the sides of this quadrilateral that are horizontal are going to be A and B. AB is going to make a line because they both have that same second number. The other pair of numbers that have the same second number is going to be CD. We want to know which sides are vertical. Well, it's going to be now looking at the other coordinate. Now it's going to be looking at the x coordinate. So that's going to be AD and BC, because those are the same. Let's go ahead and plot these points to double check our work and to check our answer. So in order to plot these points and to make sure that I have enough room for these points, what I'm going to do is I'm going to kind of adjust. So I'm not going to plot this straight in the center right now. Instead, what I'm going to do, well, I'm going to plot it in the center, but I'm going to count every square is going to be 2 spaces. So if my origin is here, I wrote these down earlier, but point A is 2, 3. So I'm going to run 2 and I'm going to jump 3 to get to point A, remembering that each line represents 2. To get to point B, that's negative 6, 3. So I'm going to run negative 6 and then I'm going to jump 3 to get to point B. And you can see that before we said that AB is horizontal. Here's line AB right here. Let's go ahead and plot point C, which is negative 6, 8. So again, I'm going to run 1, 2, 3, 4, 5, 6, and then I'm going to jump up 8. 2, 4, 6, 8 for point C. And there's our vertical line that we talked about. And our last point is 2, 8. So I'm going to run 2 and jump up 8. And that's going to be point D. You can see that right here we have roughly a rectangle. You can see that we have our horizontal sides and our vertical sides. Now they wanted us to find the area of this shape, so let's go ahead and find the area, which is going to be measured. This is 1, 2, 3, 4, 5, 6, 7, 8 across, and going up and down is 1, 2, 3, 4, 5. So to find my area, I'm going to multiply the length times the width, or 8 times 5, to get an area of 40 units squared. Go ahead and take a look at these sides. See if you can identify which ones are going to be horizontal and which ones are going to be vertical. Let's go ahead and let's check our work now by plotting these points. So again, we're going to go down here. We have a much smaller area that we're working on now. Now all that we need are -1 and up to 2. So now each of these squares can go back to being represented by 1 block. Put my origin right at the center there. So for letter E, we were going to plot -1, 1. So I'm going to run -1 and jump 1 for point E. For point F, we're going to run 2, and we're going to jump up 1. And here you can see that E and F are horizontal. For point G, I'm going to run 2, and then I'm going to jump -2. So you can see that F and G are vertical. For point H, I'm going to run -1, and I'm going to fall -2, so that you can see the horizontal and vertical sides. This shape ends up being a square because each of these measures 3 units on each side. So to find the area of that, that's going to be length times width, or 3 times 3, which is 9 units squared. Here's my original shape. And up here, nope, not there. Up here, we had a rectangle because 8 and 5 are not the same. But down here with the square, they each side measures 3, which makes it a square. When we look at this shape and we try to identify what it is, we can see that it has 2 sets of parallel sides, which means that this shape is a parallelogram. Because both sets of sides are exactly parallel, I know that because this is 25, this side's 25. Because this side is 15, this side is 15. However, when I look at this shape is not a parallelogram because both sides, while they are parallel, only one set of sides are parallel to each other. I can see that this measures 25 and this measures 24, which means there is a slight difference between the direction of this side and the direction of this side, and eventually they're going to end up touching each other. That makes this shape a trapezoid. Go ahead and try to pick out which 2 are parallelograms and which 2 are trapezoids. You should find that we have a trapezoid, a parallelogram, and a trapezoid, because parallelograms need to have both sets of sides measuring the same amount. Trapezoids will only have one set of sides that are parallel. Parallelograms end up having same measured sides. Excuse me. This shape right here between 24.2 inches and 24 1/5 inches, if you pay attention, you're going to notice that these are actually the same number. One is in fraction form, one is in decimal form, making this a parallelogram. All right, now we want to take a look at this shape and figure out if it's a parallelogram or a trapezoid. Take a minute, write down which ones you think are on the same horizontal or vertical lines. Write down if you think this is a parallelogram or a trapezoid. Let's go ahead and graph it to find out. So we're going to go ahead and make our coordinate grid. And again, if you want to look at the numbers while I'm doing this, you are welcome to go back. Our first point A is 2, 4. Run 2, jump 4. And that's going to be for point A. Point B is -5. 1, 2, 3, 4, 5. 4. 1, 2, 3, 4. And I can see right now that points A and B are on the same line. Awesome. Then I have point C, which is -4. 1, 2, 3, 4. -2. 1, 2. Point C right now is not on the same exact line as any other number, but B and C are similar, are on a line, which is great. C could also line up with A, but because we know we're making a shape, that's not the direction we're going to go. Then we're going to run 3, 2. 1, 2, 3, 1, 2. And we can see right here, C and D are on the same line. When we look at these 2 sides, BC and AD, what we see is that they have the same slope, which we're going to talk about later. But these are parallel lines because BA is 1, 2, 3, 4, 5, 6, 7 across. CD is 1, 2, 3, 4, 5, 6, 7 across. We could have also checked that by looking at BA and seeing that 2 and -5 are 7 across, and by looking at CD and seeing that -4 and 3 are 7 across, which means that this shape ends up being a parallelogram. Let's go ahead and take a look at one more quadrilateral. We're going to look down here. I want you to look and see which points are on the same horizontal or vertical lines. Are the lines horizontal or vertical? Find the lengths of both sides to figure out if the shape is a parallelogram or a trapezoid. Let's go ahead and graph this one. Go ahead and create this right here. So point E was at -2, 3. Point F was at 3, 4. Run 3, 1, 2, 3, 4. Not exactly on the same line, but you know, they connect. Then we look at point G, which is at 3, 3. 1, 2, 3. 1, 2, 3. Nope, forgot to close my parentheses. And then we look at point H, was at -2, 1. And now what we can see is that this is not a parallelogram. This side measures 1, this side measures 2, which means that this has one set of parallel lines, great, but it is a trapezoid. And we could find more with the decimals, but due to time, we're going to keep on going. The last thing we're going to look at is we're going to look at this shape. Take a minute, try to figure out what shape this is going to form. Are any of these points on the same horizontal or vertical line? Let's see if we can figure out how to find this area. So what we're going to do is we are going to create a nice coordinate plane here. You can see that I put the center a little bit differently this time, not a huge deal. Point A was 2.1, 4.4, so I'm going to run 2 1/10, which is just a little bit more than 2, and then jump up 1, 2, 3, 4. 0.4, which is just under half. So it's going to get kind of hard to be precise here. We're going to do the best we can. This is going to be point A, 2.1, 4.4. Then we're going to go to point B, which is run -2, jump 4.4, which is going to be the same line as A. So I just need to line that up all nicely. -2. That's going to be for point B. And then we're going to go, that was -2, 4.4. Then we're going to go to point C, which is going to be run -2, fall -2. And you can see that we have some points on a straight line, either horizontal or vertical, and then that last connection makes this a triangle. To figure out the lengths of the sides, we can figure out AB pretty easily because the 4.4 is the same. So I'm going to take 2, the distance from this point to 0, plus 2.1. So this side right here is going to be a measure of 4.1. And then I'm going to go ahead and look at this line right here, which is going to be going, because the -2's are the same, we ran -2 for both points. I'm going to look at how it takes 2 to go from -2 to 0, and then another 4.4 to get all the way up there. So this is going to measure 6.4. And because these form a right triangle, to find the area of this, I would multiply half times the base times the height. So half times 6.4 times 4.1 in order to find that. I'm going to go ahead and find half of 6.4 first. That's just dividing by 2. That's going to end up being 3.2 times 4.1. And now I'm going to skip over here and multiply 4.1 times 3.2. 2 times 1 is 2. 4 times 2 is 8. Done with the 2. 3 times 1. 3 times 4. 8, 9, 10, 11, and that would end up being 1312. There are 2 numbers after the decimal, so I'm going to put 2 numbers after the decimal here. The area would be 13.12 units squared. Ladies and gentlemen, I hope that the rest of your day is absolutely fantastic. Have a good one.